Hey everyone, in previous lecture I already discussed what is functional dependency, the dependency between attribute called as functional dependency, and how to identify a functional dependency. If two tuple A value is same, then their B value must be same. Means if T1 of A equals to T2 of A, then T1 of B should be T2 of B. Next I will discuss closure of set of functional dependency. Closure of functional dependency and closure of attribute both are different. First I will discuss closure of functional dependency, next I will discuss closure of attribute. We have set of functional dependency, let F, then from that we can find some additional set of functional dependency, let small f. From set of functional dependency we are finding another set of functional dependency that's called as logically implied. Given a relation schema RR, a functional dependency f on R is logically implied by set of functional dependency f on R if every instance of RR that satisfy f also satisfy f. Means if it satisfies old functional dependency, then it must satisfy the new set of functional dependency. So how we will find this new set of functional dependency? There is a set of rule. By following that, we can find the additional set of functional dependency. Let's see one example. We have a relation schema R, A, B, C, G, H, I and set of functional dependency. These are the functional dependency. Now you can see B is dependent on A, H is dependent on B. So by applying transitive rule, we can say A implied H. This is our F set of functional dependency. From this, we can find additional functional dependency, that is A implied H. So this A imply H logically implied by this set of functional dependency. The closure of F, or you can say F plus, is the set of all functional dependency logically implied by F. So how we will find that logical implied set of functional dependency? There is an axiom called as Armstrong's axiom, that is a collection of rules that help us to find logical implied functional dependency. We need to apply this rule repeatedly till we get all the functional dependency. First is reflexive rule. If B is subset of A, then A implies B hold. Next is augmentation rule. If A implies B, we can add some another attribute, let G with A, and that also will add with B. So G of A implies G of B hold. Next is transitive rule. If A implies B, B implies G, then A implies G also hold. These are the basic rules like reflexive, augmentation and transitivity. There are some additional rule like union rule. If A implies B hold, A implies G hold, then we can do union of this B and G. So A implies B, G also hold. We can do union, we can also do decomposition. Means if A implies B, G hold, then A implies B and A implies G also hold. That's called as decomposition. We can do union, also we can do decomposition. We can split the right side or we can combine the right side if left side is same. Next is pseudo transitive rule. If A implies B hold and GB implies D hold. A implies B means by using augmentation rule, we can write GA implies GB. So A implies B, from that we can write GA implies GB and GB implies D hold. So GA implies D hold. That's called as pseudo transitive rule. First we use the augmentation rule, then we use the transitive. So GA implies GB, GB implies D. So GA implies D. So these are the 6 rules by following which we can find logically implied functional dependency. We can find the functional dependency closure. And this is sound and complete as it don't generate any incorrect functional dependency and it generates set of all functional dependency. That's why it is complete. Let's see this same example. These are the set of functional dependency given. Now A implied B, B implied H. So A implied H by using the transitive rule. Next, CG implied HI. CG imply H, CG imply I. We can use the union rule, so we can combine H and I. CG implied HI. AG implied I. A derive C is there, CG derive I is there. So we can add G here. A G derive C G. Then CG derive I by using transitive AG derive I. We are applying pseudo transitive rule. Okay, that last rule. So these are some additional functional dependency that logically implied to the functional dependency given. The left hand side and right hand side of functional dependency are both subset of that relation. If there are n attribute, then there can be 2 power n subset. So total 2 power n, 2 power n, 2 power 2n functional dependency, where n is the number of attribute in R. Suppose n equals to 3, like there are 3 attribute A, B, C, then how many functional dependency possible? So 2 power 2 multiplied 3. In left side, there can be A, B, C, all possible subset 2 power 3. In the right side also there can be A, B, C, so 2 power 3 possibility. Total there can be 2 power 3 multiplied 2 power 3, that is 2 power 2 multiplied 3. It's 2 power 6 functional dependency possible. In today's lecture, I discussed how we can find functional dependency closure. There are some set of rules. By using that, we can find functional dependency closure, or that called as logically implied. The rules are reflexive rule, augmentation rule, transitive rule, union rule, decomposition rule, and pseudo transitive rule. These are the 6 rules by following which we can find all set of additional functional dependency. In next lecture, I will discuss closure of attribute set. Today I discussed closure of functional dependency. Closure of attribute set we used for finding the super key, and closure of functional dependency we used for finding logical implied set, to find all set of functional dependency that is possible from that. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.